Okay, so we're now recording. So welcome to the next Roses session. This is our second double-header session of the summer series. We have two talks. The first talk by Jean-Louis Foulley will be from 2:30 till 3:30, the first hour UK time. And then following on from that will be Vincenzo at 3:30 till 4:30. Both will talk for about 45 minutes, and there will be time for Q&A. If you can keep your microphones on mute for talks, and if you want to add questions or put in comments, please do in the chat window, and we can then have a time of Q&A, 15 minutes or so at the end of Jean-Louis' talk, and Vincenzo's a little bit later. Jean-Louis Foulley from the University of Montpellier in France. He is going to talk to us on the assessment of probability forecasts of Champions League group stage outcome based on scoring rules. Jean-Louis, please do take it away.
Okay. So you can see my presentation or not?
I'll tell you. Yep, perfect. Yep.
Yeah. So where I can access it. I don't see you, no? I just see the presentation. That's okay.
That's right. It's a very peculiar thing, but we can hear you, so do take it away.
Okay. So you see the presentation now can start?
Yeah, yeah.
Okay. So you introduced, thanks a lot, James, for having accepted my proposal of talks, and thanks to all of you to attend this session at a time where usually we are doing something else. So first, have a quick look at the contents of this presentation. After a brief introduction, I will set up the objectives, give you basic statistics about the Champions League, describe the model used to make the probability forecast, now describe the scoring rule, which is at the heart of this presentation, give you some result, discuss a discussion and a list of reference. Now, I'm not an economist, but I get interested in some of them, especially this one, and his book, Thinking Fast and Slow, chapter 18, he gave an impressive list on many occasions to forecast, from economists and financial analysis to private lives, and especially like the last one, we forecast our spouse reaction to a proposed move, our future adjustment for a new job. As a matter of fact, forecasts can be made in a wide range of disciplines, weather and climate, economic and financial, medical, epidemics, of course now, international relations, media and entertainment market, and sporting events. And it dates back seemingly from Finlay in 1884 on whether or not a tornado in the USA. Regarding football, we have in fact to study two kinds of results. The results themselves in terms of home win, draw, home loss or away win, WDL, which is categorical, or score lines in terms of YA, YB, number of goals scored in a match A versus B, which are integers. And we can forecast each of them based on, for instance, results. We can forecast directly from result or for the result and or for score lines. And it's the same for score lines. Second point, we have two different kinds of forecasts. We have the so-called point forecast, when you choose a given category, for instance, win. And we have probability forecast, as for instance in red. And I strongly suggest you to have a look at the review by Reade, Singleton, and Brown last year, who explain very well all these things. Now, the subject of this presentation is about the UEFA Champions League, the so-called C1, and I'm interested in evaluation of probability forecast of the WDL over the recent years, and I chose the last four seasons, 2017, 18, 19, 20, and each probability will be based on data from the three previous seasons. For instance, in 2020, we will use data of 2017, 18, 19. And I will study here the first part of the tournament, the so-called group stage, which is made of 32 teams distributed in 8 independent groups of 4 teams each, F to H, playing in each group 12 matches. That makes a total of 96 matches, played from September to December. Now I will give you basic statistics about the wolf file studied in this study that makes a total of 744 matches, and I will discuss home and away goals and WDL results. First, a distribution of goals scored by teams at home, playing at home, and as you will see, the most likely outcomes is 1 goal. It's in blue. The observed data are in blue. The observed histogram is in blue, 31, followed by 0 goals, 22, and 2 goals, 21. And in orange, this is the adjustment using a Poisson distribution, and in gray, not negative binomial one. As you can see easily, the negative binomial is doing better than the Poisson. Now, the same thing for goals scored by the teams playing away, the away goals. Now, the most likely outcome is 0 goal, 35%, followed by 1 goal, 30, and 2 goals, 20. Again, the negative binomial seems to make a better fit than the Poisson, with here a shortage and here an excess. In summary, if we summarize these 2 histograms, home and away, we have an average number of goals of 1.71 for home goals and 1.23 for away goals, a total of 2.93 goals per matches, a ratio home to away 1.4. And as you can see from the chi-square and p-value, the negative binomial with low chi-square and high p-value is doing a better job than the Poisson. Now is the joint distribution of home and away goals. And this is a nice picture, but not really meaningful for statistical points. So I will prefer to discuss this one. So here in rows, you have the home goals, and in column, the away goals. Above, this is the number observed for each category, scaled to 1,000 matches. And below, you have the difference between the observed numbers, the observed frequency, and the expected frequency under independence of home and away goals distribution. And as you can see, there is a shortage of 1, 0 and 0, 1, slide for 0, 0, in observation with respect to the expectation under independence, and an excess on the anti-diagonal terms, for instance, 0, 3, 1, 2, and 2, 1 especially, and the same for 3, 1, but especially these two. And I should point out that this excess and this shortage and this excess is perfectly consistent with Dixon and Coles in 1997 on the Premier League. Probably we can make a connection with the estimation of the correlation between home and away goals, season by season and overall, which is slightly negative 1.24, but systematically negative all over the periods. Now, concerning WDL results, you see that we have overall 48% of matches with a home win, 22 with a draw, and 30 with a loss. So it's easy figures to remember. And if we look now to the distribution year by year, it looks as if there is two periods, 2014, 15, 16, with relatively high frequency of home wins, around 50%, and a second period with lower frequency of home wins, around 45, and conversely, here a higher proportion of losses. Now the procedure will follow to derive a model for making the prediction and the forecast verification. First, we'll estimate and select models on realized outcome of past matches. And I will do that using frequentist procedures. Secondly, we'll make prediction of outcomes of the group stage future matches based on data of the 3 previous seasons. So it's an ex ante procedure using Bayesian methods. And third, we'll evaluate the probability forecast made before in 2 when outcomes of the future matches are known using probability scoring rule, ex post procedure. Now, this to establish the notation and the effect we'll take into account. Let's say we have a score line 1, 3, so ym from this match mij is 1, ym1 is 1, and ym2 is 3. What does it mean by ym1? It's the number of goals scored by I, the home playing team in mij, but it's also the number of goals conceded by j, the away playing team. It's important to see this reverse role of scoring and conceding. So that makes me define rating A, rating of the attack team scoring goals, high here, and rating D, rating of the defense team conceding goal, that is team J here. Now for ym2 it's exactly the same, but with reverse role of I and J. J is now the away playing team, the attack team, and I is the defense team. Type of distribution will consider the Poisson or the negative binomial. They are different mainly on the ratio variance to the mean, a ratio of 1 for the Poisson and a ratio above 1 for the negative binomial. And the effect will consider an effect of year, home effect, playing at home or not, rating A and D, and the interaction. Now, if we look at the GLM generalized list linear model SAS analysis using the world statistics, you see here the factors, degrees of freedom, chi-square, and p-value. As you will see, all in in yellow are very low, are very not important factors with high p-values. And mainly what is important is the home effect, rating A and rating D. So it seems not crucial at this stage to take into account, for instance, that the home effect vary according to years, or the effect of rate E is varying according to years. Now, the ML estimation under the Poisson negative binomial, practically the same, but as you can see here, over dispersion 0 for the Poisson is 1 plus this quantity, so it's 0. And here the quantity is very small with a confidence interval covering 0. So it seems not crucial to take into account the negative binomial. And if we perform the deviance analysis, log likelihood ratio test, contrasting the deviance of the negative binomial and the Poisson, we found 3 with a p-value of 8%. So it's in agreement with the previous results, not taking into account the negative binomial. So finally, the Poisson regression model we will use for prediction is a very, very simple Poisson model. So for a match ij between team ij and the score at home and the score away, the number of goals scored by the home team and the away team here. It's a Poisson distribution with parameter lambda ij1, lambda ij2, and using a log link function, we'll put a linear model on each this quantity with intercept, in fact the away effect, the home minus away, the home effect, and now the regression of the rating A, which is the rating of team I, and the rating defense is the rate of rating J, with the two regression coefficients, beta A minus beta D, because the effects are opposite. And now, if we switch to the other parameter, we have to change the role of I and J. Ri, I choose the Elo ratings of team I at time t. It's a very easiest criterion to find on the internet, and as far as I know, quite reliable for this purpose. And I use a standardization that way, minus 1800 divided by 150, to make the interpretation of beta A and beta D more easier. So beta A Ri or beta D Ri correspond to the expected strength for attack and defense of this team. And time t prime is the Elo rating taken at t prime lower than t, just as close as possible to the time of the match we are making forecast, maybe a couple of days or a week before. Now, as we proceed with Bayesian inference, we'll put priors on the parameters, parameter theta, eta, h, beta, k. And as the training sample free season is large enough, we'll take non-informative priors. Now, knowing the posterior distribution of the parameter, we can reconstruct the forecasting probability of elementary score lines of future matches. For instance, a match between ij, future matches, with scoreline uv will be the probability of y1 equal u, y2 equal v, knowing the data, and we'll take the mean of the posterior distribution of this probability taken as the product of a marginal one due to the assumption of conditional independence. So this is this quantity, the product of the two Poisson probabilities. And notice that contrary to what happened, for instance, in maximum likelihood, the estimation of a function is not the function of the estimation. It's the problem with Bayesian inference, that we have not functional invariance that complicates a little bit the computation. Y is the ex-ante score lines of the 3 previous seasons plus ex-ante LO rating of teams. Now, having these score lines, we can reconstruct easily the probability of win by summing over the lower diagonal of the matrix and the probability of draws by summing the diagonal elements of the matrix. Now I will move to the probability scoring rules. And this concept, I was completely unaware of probability scoring rules, never heard about it in my stat courses, and I discovered them via football, and I realized that they are coming mainly for the meteor research and the famous Murphy and Winkler framework. I strongly suggest you this paper by Robert Winkler in 26, which was given to the Spanish Statistical Society. Very good paper. I have a book by Joe Life and Stevenson also. Several papers by Alexander David, one in Encyclopedia of Statistical Science, 1986, another one, 2040, theory application of proper scoring rule. And the reference paper is this one, 19 and Raftery, 2007 in JASA, Journal of American Statistical Association. Now, I remember the first time I was faced with scoring rule when I read this this little article by David Spiegelhalter, 2009, where he said predicting is easy, predicting accurately is hard bit. It was about the last match to be played in the Premier League. And it's a very, very easy paper, but with very interesting comments about all this concept. So we have to quantify the uncertainty of forthcoming event. And what should be realized at start, that there is a superiority of probability forecast over categorical forecast, even economically. It had been shown by Winkler and Murphy, and theoretically by Savage. So it's an important thing that it's always better to forecast in terms of probability than in categorical ones by choosing one category. In fact, this is related to the Bayesian decision Bayesian theory of loss function. So I won't enter in much detail. And the purpose is to reward or penalize people for forecasting job, rank procedure forecasting, or rank people making forecasts as bookmaker, tipster, expert, modeler. Now, what are the main probability scoring rules? I gave you a list of 5 ones: the linear score, the Brier score, famous Brier score, rank probability score, negative log score, and 0-1 score. So what's the linear score? The linear score, what we call lin P vector P, P1, P2, P3 for 3 categories, and J, the result that will be observed after the, when knowing the event, is Pj. What does it mean? We reward forecasts with probability Pj when the event observed is J. that says in good sense. You know, if you give a high probability to an event and it happens, you get the highest reward. But actually, it's not due because stating, as we'll see, overstating probability to 0 and 1 if you know the rules. And now, in January 1950, came in this meteorologist, Brier, with this funny little formula, Fij, the probability forecast minus Eij square over all combination of Ij. And it's just to show you that if you want to leave your name on a procedure or on a score, you don't have to write hundreds of pages big, because it's just a 2-page article. So what is the Brier score? Brier score is simply a quadratic score contrasting the probability P1, P2, P3 with the observed results. And the observed result being in terms of 1, 0, 0 if its response in 1, 0, 1, 0 if the response is 2, and 0, 0, 1 if response is in 3. And notice that this quantity is positive. It could be written that way. Sum of the square probability minus twice the probability of the other event observed plus 1. And it's non-local because it depends on the probability forecast of all categories. Now, I'll consider the Brier score for binary events. And this score, let's say we have one event with probability P, and this event is, it happens with probability P, and it doesn't happen with probability 1 minus P, and it's the element, the observation is 1 if it happens and 0 if it doesn't happen. So it's P minus OJ square. Now, if we treat this event with the Brier score, we'll find P1 minus OJ1 square plus P2 minus OJ2 square, because there are two categories. But P2 is 1 minus P1 and OJ2 is 1 minus OJ1. So you realize immediately that the Brier score will be twice this quantity. That's why I call it the half Brier score for the single event described here, the binary event. Now remember, the Brier score is this sum over the three categories. So you realize immediately that the Brier score is the sum of the half Brier score for win plus half Brier score for draw and half Brier score for loss. So if you compute the half Brier score for each this event, considered as an all or known event, you will get easily the total Brier score. Now the rank probability score, introduced by Epstein in 1969 and popularized recently by Constantino and Fenton. It's exactly the same as the Brier score, instead that calculating a deviation category by category, it will work on cumulative probability and cumulative observation. And so instead of a P1, P2, P3, we'll have P1, P1 plus P2, P1 plus P2 plus P3, 1. So that explains why we don't have to go to 3 here in the summation. And now OJ1, OJ2, OJ3. So if the response is in one category, first category, we will have 1, 1 plus 0, 1 plus 0 plus 0. That makes 1, 1, 1. OJ, O2 star response in the second category 0, 1, 1, and response in the third category 0, 0, 1. So let's say we have a response in last category. We'll have 1/2 P1 minus 0 square. Here we are, P1 minus 0 square, plus P1 plus P2 minus 0 square, plus the sum minus 1, so it's cancelled. And what is this quantity? Is P3 minus 1. So in fact, this rank probability score is the average of the Brier score for win against the two others and for loss against the two others. So in fact, the rank probability score is the average of half Brier score for win and half Brier score for loss. The negative log score is very simple. We reward the probability forecast of the observed event by minus the log of this probability, minus to have a positive number. It's the same as before, negatively oriented, because the smaller is the better. It's equal to half the deviance in statistical theory. It's positive, negatively oriented, and it depends only on the probability in category observed. It's called the local score. Now the 0-1 score, Knighting, Raftery described Asti, Tibshian, and Friedman. It rewards 1 if the category observed is the most likely outcomes on account of your forecast, and 0 otherwise. It's including in the list of probability scoring goal by Knighting and Raftery, but it's viewed mostly as a categorical classifier. So it's liable to specific tools, deterministic forecasting tools such as the confusion matrix. Now an example, it's the match PSG against Manchester United in round 16, March 6 last year. In England, PSG beat Manchester 2-0, and in Paris back, these are the forecast by Reade, forecast by myself, or forecast derived from the odds portal. And the results were 1-3. In fact, Manchester United was qualified because they had scored more goals outside. So how you can compute the scoring rules? We will compute for win, draw, and loss. For win, it's this minus this square. So this is the result. For draw, 0.27 minus 0 square, this is this, and for loss, 0.28 minus 1 square, this is this. So you had this three quantity and you get the Brier score, and you take the average on these two, win and loss, and you get the rank probability square. This is the values of the, in fact, for the 0-1, everybody got 0 because nobody, the most likely outcomes for everybody was 1 and the result was 2, so it was 0 for the 0-1 score. And here you have Reade, myself, and odds portal, and the smaller is the better, so Reade was definitively the best here. Now, if observed results is J, if this result is sampled, the score has a distribution, and it's natural to consider its expectation. So the expectation of a score, which is written as SPQ, is expectation with respect to X of this quantity. So it's the score times the probability, the sum of the score times the probability that Px equal J. So it sums to J equal 1 to 3, Qj SPJ, where Qj is the real probability that X equal J. So now we have on the scene the true distribution and the outcome, the Qs. We have the forecasted distribution here, P, and we have the true distribution, Q. An SPQ is estimated by the empirical score on a sample of matches M from 1 to big M with forecast probability PM for each match and observed result XM. So we'll sum over all the matches the score and divide by M. And we get the empirical score, which applies an estimator of a score function even when P is heterogeneous, as is the case in football. Now the property, so we have seen the score of penalty for the Brier wrong probability score and negative loss score, so negatively oriented, positively oriented, linear score, and 0-1. Locality, local depends only on what is observed, negative loss score, 0-1 score. It's consistent with the likelihood principle. Only observed values are relevant in inference. Sensitivity to distance favors adjacent category, like in RPS, Constantino and Fenton. And this is the argument he put forward to take into account that, for instance, draw is closer to win than to a loss. Properness, improper, proper, and strictly proper. These are important properties I'll talk about now. So if we consider a negatively oriented score, this quantity should be higher than this one being calculated with the true distribution of outcomes. And if we check that, the score is proper and is strictly proper if this zero only if P equal Q. And that's the case for Brier, wrong probability score and negative log score. Let's look, for instance, at the binary score for the half Brier score. If the result is 1, we'll have P minus 1 square. And if the result is 0, we'll have P square. This happened with probability Q, because the probability that G is equal to 1, and this happened with probability 1 minus Q. So we have this quantity, Q P minus 1 square plus 1 minus Q P square. Now, if we apply this quantity with P equal Q, we get this quantity, Q1 minus Q, and the difference between this one and this one is P minus Q square. And you can see right now by this decomposition what the Brier square means. It means a term which is Q1 minus Q called sharpness. Sharpness is can be qualified that way. Perfect probability are towards 0 and 1. So the more you are going to 0 and 1, the more you are sharp, you're sharper. And this quantity is the calibration, P minus Q square. That means that how close are your forecasts to the real ones. So you have to work on both sides, and maybe it's contradictory sometimes to have, for instance, a big sharpness and at the same time it's hard to be calibrated. Now for the other score, the linear score. So I derive the formulae for SPQ. So it's sum sur Q, so sum over KP KQK. SQQ is the sum of QK square, and here is the difference. This difference should be negative to have a proper score. And in fact, for instance, if Q1, the real probability of category 1, is above 1/3, then taking P1 equal 1, you will get a D which is positive, indicating that the score is improper. On the contrary, with the Brier score, SQQ is 1 minus Q squared, and DPQ is this quantity, PK minus QK squared, the sum, which is obviously positive. And as the score is negatively oriented, this quantity should be positive to be proper, and it's obviously positive. The same for the negative log score. SQQ is this quantity. Remember, log of the probability. Here, the forecasting probability is replaced by the real probability, and it's the weight, QK. And for who knows, this is the entropy. And now the D is this quantity, and this quantity is the so-called Kullback-Leibler distance between Q and P. It's known, very well known, it's positive. So these two scores are proper and even strictly proper. Now by results, in average for the 4th season, the Poisson regression model performed that way: 0.54, 0.18, 0.92, and 0.58. And as compared to what I called OHM, OHM is the forecasting with the same probability for all the matches that serve as a reference by just taking into account the OHM effect. So remember, the OHM effect was something like 48% as compared to 22 draw and 34 loss. So I take this constant probability for all the matches, and I get this. As you can see, we are making some improvement with respect to this naive forecasting procedure. We improved by 18%, here 22, and here if we take the difference, we call the skill, we have 0.16 and 0.14. I also included the performance of what I call the bookmaker. That's probability forecast derived from the odds given of odds portal as the mean of 10 to 12 betting sites. And as you can see, they're a little bit better than us. For the Brier score is about 5%. Here it's very light on the run probability score, also 7%, and 4 here and 2 here. So it's slightly better, but not dramatically better, I would say. Now the results over the 4th season, they are consistent over season, except that in some sense the last season was really good. And it's the same for the bookmakers, so it's not due to some mistake in my calculation. It's due to the fact that the models are working better this year. Now it's a comparison we made with James at the end of the group stage in this year. And James computed the half Brier score for each eventuality, home, draw, and away, and home, draw, and away. And you can see on draw we are practically the same, but we are a little bit better on home and away, resulting in this value for the Brier and run probability score. Now, uncertainty about PCR. If forecasting probability is based on a model, the probability are uncertain. There is some error in these probabilities, and we can take into account this error also at the level of the score. And this can be done easily by Bayesian treatment. And we see here the posterior distribution of the score, Lin, Brier, RPS, and deviance, and the 95% credibility, and here the mean. So it's why I suggest, instead of having a plug-in version of P, here putting the posterior expectation of a probability, taking rather the posterior expectation of the score. And we take automatically into account the uncertainty in the probability. Now, comparison with a couple of other studies, Grohl in the World Cup. As you can see, the Brier score is about the same level, and the RPS a little bit higher. Grohl for the Euro, not better here, not better here. And a couple of studies about the Premier League, Lay and co-workers, reported for Poisson bivariate, a complicated model, or direct evaluation, probit these quantities, which are not better than this one. Same for Atum and Arsen. Same for Roux and Salvesen in 20. And Goddard, And the last one is Constantino, who developed a kind of omnibus method for all kind of competition. He tested it on 206 match, and he got this RPS. So the discussion rapidly. Probability score are almost mandatory in evaluation of probability forecast of football WDL results. Restrict use to proper score. There is a debate about the wrong probability score and negative log score. See Whitcroft in 2019. Interesting feature of log score, locality and likelihood based. Log score is closely related to the Kelly criterion for betting, so it can be a better score for those who want to earn money. Combining probability score forecast is probably a key issue to improving the forecasting. And you can also construct your own utility or loss function. Last, I will mention that other methods might be used for those who are not at ease with the scoring rules. We can use the joint distribution outcome and forecast, and for instance, make a regression or observe outcome of forecast, what is done in the paper by Reade, Singleton, and Brown. Models. We observe same results efficiency for Poisson or for Davidson model directly on WDL. So there is no real improvement using a scoreline model. Surprising efficient with this efficiency for this very simple model with 3 to 4 parameters. And I'm not surprised when I read this paper by Pinero saying incorporating covariates allows intergroup variation, here team ability, to be explained via fixed effects. So in that sense, the inclusion of covariates leads to removal of random effects. It's a substitute to random effects, very efficient one. Model, avenue for many possible improvement. I've listed some of them here on team-specific home and away effect, changing rating of team, each home and away relationship. So many possibilities, bivariate Poisson, Carlis and Zufra, scopulars, Nietzsche model, Bayesian network, and so forth. And there is an advantage of Bayesian procedure to obtain the results. Acknowledgement on James Reade for hosting my forecast on this website and challenging confrontation with Reade, Gilles Soleux, Lo Ndai, and Maxime Taillarda, meteorologist in France, for his comments and explanation of the scoring rules. Thanks. I'll get back to you. Is it okay? I've finished.
I'm just trying to unmute myself. Yeah, yeah.
James, you muted yourself.
It was incredibly slow, and it's like about 10 seconds between anything I click and anything that actually happens, which is quite hard work. Between the talks, I will restart my computer. But in terms of discussion, Carl mentioned, or Carl was, I was quite intrigued as well about your plot looking at the change in the home proportions in the league between these seasons. And the question was whether there was any kind of change in the structure of the competition at that time. And I think it looks like it was at that point when Europa League
So you mean it might be beneficial to take home effect depending on the years, no? What's you say, no?
Well, possibly, I guess. I mean, that might be the implication from your plot, which seems to suggest quite a big difference between those first 3 years and the 6 years.
Yes. And is there any explanation for that? You change of rules or change of playing style, or what's the reason we can think about?
Carl mentioned something about Europa League winners entering the draw for the Champions League. An extra team from the top leagues was going into the Champions League from that season. So that is one of the rule changes that took place. But it's not clear why that would lead to a change in the number of home wins versus away wins necessarily, unless we just see stronger teams across the board, and therefore stronger teams always win home or away against weaker teams. Carl, I don't know if you had any thoughts on that, or Alex. Alex commented as well. And then a follow-up was on your ELO ratings, Jean-Louis.
Yes.
Do you calculate them for all European football, or do you just calculate them based on matches?
No, I just picked them from the site Club ELO.
Okay.
Internet.
Yeah.
It's very convenient and apparently quite reliable. So it's on purpose a very simple model that in fact everybody could apply with a small hand calculator, no? And that's why my purpose, using a simple model as possible, and to show that this model is quite efficient to some extent as compared to very complicated model bivariate Poisson with very complicated distribution. So it seems to me that probably the progress would be in combining different kind of forecasts than just trying to improve the model, or having a model combining itself these possibilities.
Yeah. And the final thing that I might just ask you about is obviously you and I, we interacted a lot on score forecasts as well. And you focused this presentation on the win, draw, loss.
Yeah.
And do you have any kind of thoughts about how the probability scoring rules as a way of evaluating forecasts works when we're thinking about score lines instead of win, draw, loss?
You mean for score lines?
Yeah, so 2-1.
Oh no, it's really, to me, it's too much complicated to evaluate forecasting ability on score lines because these probabilities are so small, no? And what happened, and you pointed that many times the prediction based on score line are not in complete agreement with prediction on categories, no? Sometimes with score lines, we'll have, for instance, draws, and with categories, it's very rare to have something in favor of draws, no?
Yeah.
So probably combining these two might improve the forecasting, no? Is what you said. You said conditional or unconditional, as far as I remember in Reade's your prevision.
Yeah, so we did use these conditional forecasts where you built in the win, draw, loss forecast into what then your scoreline forecast was. Absolutely. Anybody have any other questions they want to ask quickly in the last few moments? You do feel free to unmute yourself and ask a question.
So everybody is at ease with score lines.
Seems so. Okay, well, what I'll do is I'll wrap up Jean-Louis, and then we've got a few minutes for a comfort break before we reconvene. So thank you, Jean-Louis, for a really interesting talk on forecasting football match outcomes, and we'll reconvene in 3 minutes at 3:30 UK time.
Thanks.
Now I'll also restart my computer.